Welcome. My name is Andy Deal. I'm your host. I'm excited to be here with you. Joining us today is Sasan Kubriari. Sasan is our Director of PLM and Digital Transformation. He will be sharing some insights and tips to help you get the most out of AI and understanding the whole AI landscape and how you can work with AI in Teamcenter. So let's go ahead and get started.
All right, thank you, Andy. Thanks for joining. Today, we'll go over the role of AI in engineering and PLM, specifically as an enabler, give you updates on Siemens AI-powered solutions, what are the latest, and some of the use cases example. And then at the end, I would like to share with you a framework and implementation plan. I guess let's start with a quick poll to prepare, understand the audience and see what is your organization's current level of AI usage? If you can put it in the chat as far as 1, 2, 3, 4 level of your organization. Might be sometimes maybe 2 and 3. You know, you have some level of implementation, or you know, there's no AI strategy today in your organization. So just get a feel for where you're at with the AI journey.
All right, we're going to give people about 15, 20 seconds to do this. Go ahead and enter your choice into the chat box. Thank you.
All right, and as you're doing that, I appreciate it. That gives us a little bit of kind of feedback on that. But let me share with you the role of AI in engineering organization. The main point is really AI doesn't replace engineers. It removes the friction that slows engineers down. The real value shows up in 4 places: finding the right information fast, so engineers stop hunting through systems, surfacing similar designs and parts. So then teams are not reinventing what they already exist. Flagging risk early in the process before they become expensive surprises. And automation of the task and things that really doesn't really apply to engineering, they can really get a lot of benefit from leveraging AI. So AI really clears the road ahead for a lot of those challenges engineers have today. And executives don't buy AI, they buy outcomes. Anytime we are looking at any technology implementation, we first ask the question, what are the big challenges, time-wasting activities, business problems, and you always start with business pain points, and that's something we go to later. Now, let's look at focus on AI in engineering world. If I had to say it in one line, PLM is where engineering intelligence lives. AI becomes valuable when it can reliably consume design specification, engineering advice, product structure, where use relationship, configuration, change history, requirement and traceability. And that's why team-centered discipline is not a system project, it's an AI strategy enabler. And you have a lot of that information already in Teamcenter that you can leverage. AI doesn't require perfect data, it requires reliable patterns and trust. AI ready means we standardize how data is created, connect domains that should be connected, and enforce quality where it matters most, especially at release and change point.
So, question for you, Sasan. When you say AI ready data, does that mean companies need to clean up all of the historical data before they even start?
No, and that's a really important point. AI ready data doesn't mean perfect data. It means reliable, structured, and governed data going forward. The fastest way to improve AI outcomes is not to clean 20 years of data. It is to stop creating bad data today. So let's have another question to the audience. What is the biggest barriers you see for adopting AI in your organization? So you have 1, 2, 3, 4, 5, and sometimes it might be multiple. If you can just enter that in the chat, that would be great.
Yep.
Data
So we'll give
quality,
another
lack of
15.
governance,
Sorry.
ITAR concerns, ROI, really selling out to the executives, and change management adoption. And you may have multiple of those challenges.
Absolutely. So if you have multiple choices, just enter the number, whatever choice fits your situation, and just type in a chat, and we'll give it another 10 seconds or so. Thank you.
Great, thank you for your input. And so you need to build the trust with AI results. AI can produce answers that sounds confident, but are factually wrong. So you have to be very careful when you're looking at AI results. So AI fails more often from data issues than algorithm issues. There's a lot of very strong large language models out there, but it's all about how they're using the data. So unclear configuration data, fragmented change records, and silos between CAD, CAE, and manufacturing, and quality and others really causing some of the failures in really having trust in AI output. So looking at the perspectives of an engineer, we can broadly identify 3 benefits that engineers are looking for. Improve user interactions. You got to make it easy to use. Innovative design support, help engineers finding new unexpected solutions. In your complex systems nowadays, which has hardware, software, and electrical, mechanical elements all together, the possible variations are virtually unlimited. As humans, we will typically go for certain solutions that look logical, but maybe there are unorthodox ideas that lead to better results. So AI helps to broaden our view here. So faster decision making is another thing that engineers are looking for. So AI can assist on speeding up the process. So let's look at some of the Siemens AI offerings. Siemens invested in deep learning starting back in 2015 and has hired hundreds of AI engineers over the last 5 years to implement AI technology within the solution set that you're already using. Teamcenter AI Value, Teamcenter AI Chat, NX AI capabilities, simulation and cost AI, and much more. Siemens is also developing an industrial foundation model that will underpin our own AI solutions and allow engineers to fine-tune their solutions as well, accelerating the introduction of AI solution in industry. So we all have used large language models for years now, for a couple of years at least. And now the models work on text, images, videos, and audios. But AI engineering has its own language. They must understand system design, specifications, mechanical, electrical design, simulation, manufacturing, BOM, and product configuration. And that's what Siemens Xcelerator AI framework delivers the required platform to really work in the engineering world. This framework shows how Siemens embeds AI directly into engineering and PLM ecosystem, not as a separate tool, but as a part of a digital thread. At the top, you see the intelligent interface, a command chat-based experience that works across applications, allowing engineers and users to interact with PLM using natural languages. Beneath that is agent framework, which orchestrates different AI capabilities, Q&A, reasoning, and engineering specific tools, based on user input, not menus or modules. The RAG pipeline ensures AI responses are grounded in trusted enterprise data by retrieving real context from Teamcenter, documents, and other sources before generating answers. Engineering modularity connect AI directly to domain workflows, mechanical, electrical, simulation, manufacturing, and BOM. So AI can reason in engineering context, not just text. All of this is powered by source, secure, data sources, pulling from Siemens and customer systems through a single control pipeline. The infrastructure layer provides enterprise-grade security and scalability and embedded models without exposing sensitive IP. The key takeaway, engineers can deliver PLM with natural language, create and reason over engineering data faster, and reduce friction without compromising governance or data ownership.
So, Sasan, sorry to interrupt, but I have another question for you, and I'm sure many of our audience member may have the same questions, right? So it's clear that Siemens is making heavy investment into AI and PLM integration. Looking at all the information that you're presenting here, could you help us understand which of these powerful AI capabilities are available today to implement and leverage versus what's still being worked on in development and maybe available in the future?
Sure, as you see with AI in industry, is a lot of improvements and new capabilities are coming every month, every week. You see something coming out. So Siemens is also investing a lot, and what you can likely interact with PLM today, you can use natural language, get reliable answers, ground it in your company's data, and benefit from secure, scalable platform. There are significant productivity boosters right now that you can use with your existing applications with the new releases that AI has been embedded. I'll show you a couple of examples later. And then, of course, the holy grail of AI agents that you hear a lot can truly understand complex engineering intent, orchestrate multiple tools autonomously, and perform deep cross-domain engineering reasoning is where much of exciting ongoing R&D is concentrated. This is where we'll see continuous breakthrough and expanding capabilities in coming months, coming years. And I'll show you a couple of AI use cases that demonstrates the current capabilities.
Okay, great.
And Siemens is also evolving the Teamcenter user experience with AI to help engineers work in Teamcenter more naturally and productively. Teamcenter Copilot is a Gen AI powered assistant for engineering productivity. It is embedded in Teamcenter and brings together document intelligence, BOM exploration, and conversational search into a single intuitive interface. The Copilot provides secure and intelligent context-aware assistance. So let's look at one of the existing AI features in Teamcenter. Teamcenter AI Chat is an AI-powered chatbot that enables you to query documents-based product knowledge managed in your PLM environment. Using natural language, you can pose questions to chatbot and receive responses that are grounded in your company's data. It also provides links to source files that is, pretty much you have in your company database. So in this video, it shows example of how Teamcenter AI Chat responds to a set of user queries related to a solid state contactors. Notice how Teamcenter AI Chat provides clear and focused responses on these questions, along with direct links to the standard documents that inform your responses, all within a couple of seconds. Asking what factors are important to solid state contactors from company documentation that shows the related factors with its relevance and initiates a change. So that's pretty much taps into the company information to provide that kind of insight to the engineers. And then for years, we have used Teamcenter really well as a system of record. It manages our data, our BOM, our change processes. But the shift happening now is important. Teamcenter is evolving from just managing data to actually helping us think with that data. Instead of searching, navigating, and interpreting everything manually, the system starts with to understand context and guide you. So the goal here is simple. less time managing data, more time making engineering decisions. There are a few key technologies making this possible, but I'll keep it simple. First, large language model. That's what allows you to interact with Teamcenter in natural language instead of searching by fields or filters. You can ask real questions and get contextual answers. Second, agents. Think of these are as digital assistants. They don't just answer questions, they can take actions, like initiating a change or running validation. And probably the most important piece, that this AI is grounded in your PLM data. It's not guessing, it's using your BOM, your change history, your documents securely, and that's what makes it usable in engineering. Another short example of AI in NX. I showed you the one in Teamcenter, now is NX, and there's many, many other examples, but because of time, I'll just show you a couple examples. So this is engineers designing a mount assembly part. So engineer is asking AI for some pointers. So it combines with already the knowledge which is built in Teamcenter for how to best practices are done. Also can tap into your design specifications and your knowledge base of the company, which are very specific for your design best practices. So engineers can ask questions like how to update the bracket design by editing the sketch. Copilot provides step-by-step instructions, and then they can go look at the instructions, and then he also gives you where are the sources of that instruction, which is very important because you want to make sure it's tapping into the right source of data and not hallucinate, which you've heard the term. You can continue, and engineers can ask questions on, can you help making this change if design was component of assembly? Again, these are some of the best practices which is embedded in NX, or it can also be some of the best practices that you have documented throughout the company. You can ask questions on how to add bodies for analysis using performance predictor. And you can see how strong of a solution that can be for the young engineers who are coming to the company and they're just learning how to use NX, how to do CAD-CAE integration, and then it kind of guides them through step by step. And then ask more further questions. Can you help me with assigned constraints? And then it just goes through, look at the information and start giving you some pointers, and you can follow it step by step. Help me to assign loads using performance predictors. So again, for engineers who may not know CAE as much, then they can really help them to teach some of that expertise with them as well. What kind of load can I apply? And then just goes on. So you can see that this is something that engineers had to go through and really dig into a lot of documentation in the company and try to find, or really ask for other experts in the company to be able to get the information.
So I have a question that's kind of related to this, to what you just showed.
Sure.
Question came in, can the company info/standards be located on SharePoint? I guess I'm assuming he means that can it be like put in the system so that everybody has access to it and ask questions about
it? And that's what the Copilot really comes into play, because Copilot Teamcenter integration, then you pretty much tell the Copilot engine what are the where are the location of the documents that the system is allowed to look at, so they don't go off on the internet and try to get some information which may not be accurate. So you can control the documents that the system looks at. So you can put your design specifications. Of course, you have all of your knowledge in Teamcenter already with bill of material, change history, attributes, and designs. And then you can also add a lot of the design specifications, requirements, and the best practices of the company, and then points Teamcenter Copilot to those locations that is allowed to look at.
Perfect, thank you.
So Siemens AI platform acts as catalyst across entire engineering lifecycle, from requirements through operations. AI is embedded in every stage, helping teams move faster and make better decisions earlier. During concept design, AI supports architectural exploration and performance. In manufacturing, ensures manufacturability before release, and in operations, continuously validates lifecycle performance. So as in each of these design phases, you can see that AI has been embedded in Siemens solution. The key shift is simulation-driven product development with continuous feedback, connecting mechanical, electrical, and software disciplines end-to-end instead of optimizing each phase in isolation. So let's look at some of the examples of AI use cases in engineering world. These are generic engineering words examples, and mainly, this just eye chart. I'm not going to kind of read through it, but that's just for you for later on. It's really to get some ideas for your organization, so you can look at the example of what AI can do, and then look at your own pain points and problem areas and see how you can leverage. The highest impact areas of new product development companies are design R&D, manufacturing, quality, operations, and design, data, and knowledge. So, and then these are specific use cases highlighted the power of integrated digital twin approach within Siemens design solutions, where data from various Siemens tools fuels AI for significant business impact. So I've kind of listed 10 of them as an example, again, to show the description of the problem, the tools that can be used with AI-enabled capabilities, and then the value it brings in. And each tools with NX, Teamcenter, Ops Center, they're all pretty much there. So this is intelligent design, reuse, AI-assisted requirement analysis, example of predictive maintenance and service optimization, manufacturing process simulation optimization, AI-enhanced simulation, design verification, AI algorithm that automatically checks designs against a set of rules, the standards, compliance requirements. Again, these are all your own company design specifications and rules that are defined. And then another example of supplier performance, digital twin driven AI for product development, for example. These are some examples I've included for you to look at later. So what does it actually mean for the business? First, speed. Engineers spend less time looking for information and more time acting on it. Again, as you see in the first demo or video, that people can just ask natural language, ask questions. It's not that they have to go search the data. They just ask questions in any form, and then it goes through hundreds and hundreds of pages of information and then gives you the answer. Second is quality. You can catch issues earlier because AI can see patterns across data that are usually missed. And third is reuse. One of the biggest opportunities that helps engineers to find and reuse what already exists instead of redesigning. And overall, it builds trust in the system, because now the system isn't just storing data, it's helping validate, connect, and use it. And that's when PLM really becomes decision system, not just a storage system. So this is a kind of a summary of Siemens solutions in different layers. Siemens has built one of the most comprehensive AI ecosystems in industry, spanning every layer of the value chain from cloud to factory floor to the edge. So cloud and platforms, solutions as of MindSphere, Mendix, and Teamcenter give organizations the digital backbone to connect, develop, and manage AI-powered operations. Design and engineering, you have examples like Siemcenter, Digital Twin. Commerce has capabilities that has AI built into it. In manufacturing operations, you have Ops Center APS and AI-powered automation and robotic optimization. Again, they're all tools that you're all familiar with, but now these are the solutions which already AI is implemented and can be used today. So what makes this ecosystem powerful isn't any single product. It's that every layer talks to the others. Siemens AI doesn't just automate tasks, it creates a connected intelligence across entire industrial enterprise. So So that pretty much goes over the overview of AI capabilities with Siemens and some of the use cases. And now let's look at how do we start building an AI strategy for your organization. And of course, you can always contact Saratech experts, and then we can help you with some developing strategies or implementation. So what I've seen, and I've got that emphasized in the recent certification I completed with the Stanford AI leadership class, that really start with business issues, with pain points, with technology, not so much technology, but pain points. Before selecting any tools, ask where do engineers lose time, where do errors repeatedly happens, which decisions lack transparency, which data is least trusted. So AI should target those areas first. So first we fix the PLM foundation, product structures, BOM accuracy, configuration, and change, because AI only amplifies existing data quality. Second, we govern the data with clear ownership and standards. And then third, we introduce AI incrementally, targeting high friction areas like design reuse, variant, and change impact, focus on real workload reduction. And finally, we measure outcome, not novelty, trying AI directly to engineering KPIs like cycle time, quality, and rework reduction. So most companies don't need a year to start. They need 90 days of clarity and discipline. Pick outcomes, fix the data creation system, pilot in one workflow that matters, then decide, scale, kill, or pivot. This is a program discipline model, not a technology project. The 90-day structure forces the decision that most teams avoid, and that avoidance is exactly where AI pilots stall. This is an AI adoption journey Siemens has noticed across engineering organization the last few years. It's not a big bang transformation. It is manually mature. It's maturity curve from individual productivity to enterprise efficiency. AI maturity is a journey from helping individuals work faster to helping entire enterprise work smarter. So we can start with simple use cases, Copilot style assistance, improving individual productivity, then start improving decision quality, not just speed. AI starts assisting with decision making using enterprise data. You can start then later on with moving with individuals, from individuals to teams, standardization, best practices, reuse of knowledge, improving collaboration. And then the biggest value comes when AI leverages historical IP and institutional knowledge. This is where you unlock your true digital thread value across programs, learning, and predictive insights. AI becomes part of how the business operates, not just a tool. So the key is sequencing. Start small, prove the value, scale with governance. Organizations that move fastest are the ones that treat AI as a data and process transformation, not just a technology deployment in that sense. So the final takeaway I'd like to leave is with AI as engineering doesn't start with models. It starts with your product data and the discipline around it. Here's what to take back to your team this week, later on. Mainly to implement is name your outcome, audit your data discipline, and run the 90-day model that I presented here. Implement your AI-first engineering organization. And as always, you can contact Saratech for additional support if needed. Thank you.
All right, Sasan, there's a couple questions that came in. One is around security. So, how do you ensure that the AI environment is secure and compliant, especially for a company working with ITAR restriction and so forth?
Yeah, that's one of the kind of hesitance of companies to quickly implement AI. So Siemens uses a retrieval-based architecture with strict access control. Data stays in Microsoft 365 Azure, no model training on your data, and US person enforcement where required. So governance and access policies are built in upfront. Siemens' approach begins with extending the robust security framework of Teamcenter that you're familiar with, which is access control list, attribute-based access control, and comprehensive audit trails to ensure only authorized US persons access, modify, or even process ITAR data.
All right. Good advice. Again, we have a lot of experience with this. So if you need specific answers to your situation, contact us. Um, so if I'm a person who just saw this and I'm excited, I want to get AI started and implemented immediately in my organization. What's the first thing that you would recommend they do, especially in a smaller engineering organization?
Yeah, sure. I would start with 2 or 3 focus pilots using your existing data. Typically, proposal automation, engineering knowledge search, and design support. Then we would align access, security, and data sources upfront to ensure compliance and adoption. Within 4 or 6 weeks, you can measure impact, cycle time, engineering efficiency, and decision speed, and then scale from there as adding to more pilots, more use cases, and then it's all about training your team to be able to leverage AI every day in their day-to-day engineering process.
Good to see everyone online, and hope to see you next time on our next CES. Thank you.